we are talking about representing relationships some more. So our learning target today is I can represent relationships with tables, graphs, and equations. Please write down what you already know about this. You know what a relationship is, you know what tables are, graphs are, equations. You know a lot about these things already. We've been talking about it. We're just going to get a little extra practice on that today. And then please write down the date that you are watching this video, and we have no vocabulary today. So pause the video here, get all of that written down, and then restart when you're ready to go. The first thing we're going to talk about today is just reviewing again how to tell if a graph or an equation forms a proportional relationship. So remember, a relationship has to have two things to be proportional. Those are, it has to have a constant rate, and it has to go through 0, 0. So looking at these, if I look at the first here, this graph definitely has a constant rate. It is a straight line. However, if I look, it does not go through 0, 0. It's really close to 0, 0, but the answer here would be no, because it does not go through 0, 0. It is a constant rate. So what I would like you to do here is pause the video, see if you can identify the rest of these graphs as if they are proportional or not, and then restart the video when you are done. All right, hopefully you've tried all of these at this point. Graph number 2, I see, is a curve. Curves means it does not have a constant rate. So my answer here would be no, because there's no constant rate. It does go through 0, 0, but it does not have a constant rate. For graph number 3, my answer is still no, because it does not go through 0, 0. For number 4, it does go through 0, 0, and it is a straight line. So this one is yes. Number 5, the answer is no, it's not a straight line. It's a shape made up of a bunch of straight lines, but it needs to be the same straight line the whole time. So it is not proportional. And then this last one, the answer is yes. It goes through 0, 0, and it is a straight line. The second type of thing we're going to do here is tell whether each equation represents direct variation. Direct variation is just another phrase for a proportional relationship. They mean the same thing. Some places like to use direct variation, some places like to use proportional relationship. But it's really important that you are able to recognize that direct variation and proportional relationship mean the same thing. So, to determine if an equation is a proportional relationship, it has to be in the form y equals kx. K is a constant, so this was in our proportional relationships video. So, for example, the first one here, the answer is pretty straightforward. Yes. Y equals 4x. Y equals 4 times x. That is exactly the form. So see if you can go through and determine whether the rest are proportional or not. Pausing the video. So hopefully you've paused the video, seeing if you can figure out whether each of these are proportional, and now you are back. Looking at the rest of these, if I say look at these, y equals 4x minus 3. This minus 3 part is not in the form of a proportional relationship. So my answer here is no. Looking at number 3, y over x equals 4. Well, I know I don't like that y over x. That doesn't look nice. So I'm actually going to rewrite this. I'm going to multiply by x on each side. That gets rid of the divide by x. So now I have y equals 4x. Well, now this looks great. Now this looks exactly like a proportional relationship. So my answer is yes. For the next one, I have yx equals 4. Yx equals 4 is not the same as y equals a number times x. So my answer here is no. Looking at the next one, again, I see that I have something on the bottom. So I'm going to multiply by x on each side again to get that out of the bottom. That cancels this out. And I have yx on this side equals 4. Well, now that I have that out from under the bottom, I can see my answer is no. Yx equals 4 is not the same as y equals a number times x. And then x equals 4 doesn't even have a y, so my answer is no again. So that is the first thing we need to be able to do today. The second thing is we want to be able to take a situation and create a table, a graph, and an equation for that situation. So let's look at this situation. Arne can walk 1.5 meters per second. She begins at the starting line and walks for 60 seconds. So my first thing I want to do is complete a table to show how far she's walked at various times. So she's starting at the starting line and walking 1.5 meters each second. So that means that at 0 seconds, she's walked 0 meters. And if she can walk 1.5 meters per second, then after 1 second, she would have walked 1.5 meters. So again, please pause the video here, see if you can fill in the table, and then restart to check your work. All right, so for the rest of these, I'm just going to be multiplying each number on the top of the table each time by 1.5 seconds. So 5 seconds, she can walk 1.5 meters each second. 5 times 1.5 is 7.5. In 10 seconds, 10 times 1.5 is 15. 20 times 1.5 is 30. 30 times 1.5 is 45. 40 times 1.5 is 60. 50 times 1.5 is 75. And 60 times 1.5 is 90. So my table's filled in. Now I want to make a graph. Since this event started counting by tens on the top, well, so the top for making the graph, the top is always going to be x, and the y is always going to be the bottom. So I want to make a graph. So the first thing I see, I know that my x-axis is my time. Label that. And my y-axis is my distance. So that's the first thing I do when I make a graph. Now I want to see how big my numbers get on my graph. So for the top, for time, it goes from 0 to 60. So I think for that, I'm going to count by 5s on the bottom. Here's my 0, 0, and then I'm going to count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Now I need to do my y-axis. My y-axis goes from 0 to 90. I think I'm going to count by 5s again. I think I have enough space here. So if you need to pause the video to get your graph set up, please do so at this time. The only reason I counted by 5s is because I want to be able to go all the way from the smallest number in my table to the biggest number on my table. After I've done that, I can start plotting points. So remember that my x comes first on my point and my y comes second. So, for example, my first point is 0, 0. Graphing this on my table, 0, 0 is right there. Next is 1, 1.5. Well, this is a really small spot, so it really just goes right there. Next is 5, 7.5. So over 5, up to 7.5. 10, 15, over 10 to 15. 20, 30, over to 20. up to 30, and now we just keep going. So see if you can graph the rest of these points on your own. And that's what your line should look like. Now at the end, we can turn this into a straight line, connecting all of those points. And that is my graph. So our next question wants us to come up with an equation. So we've made a table, we've made a graph, we've needed an equation. So I'm going to look back up here at my graph, and I'm going to figure out, what did I do to each of these numbers to get each of those numbers down there? Well, she walks 1.5 meters per second. So each time all I was doing was multiplying 1.5. So my formula, my equation here, is that x times 1.5 equals y. So that is my equation. Again, all I did is I looked at my table and said, what did I do to each of the x's to get each of the y's? To get each y, I did 1.5 times each x. This is a proportional relationship. I can tell by the equation, because it's in the form of y equals a number times x. I can tell by the graph, because it's a straight line and it goes through 0, 0. And I can tell by the table, because if you remember from our last video, to check if it's proportional, we just see if we have a constant rate. Are we multiplying by the same thing each and every time? And the answer was yes. It was always times 1.5. That means that this is proportional, and we can tell it on all three ways. Okay. So our next one, New has a stamp collection. He already has 10 stamps, and this formatted weird. So each month he collects 3 more stamps. So making this table is a little different. He's already got 10 stamps. So at 0 months, he has 10 stamps already. So now we need to continue with where he's going next. Each month he collects 3 more. So at 2 months, he got 13 stamps. At 2 months, he's got 16 stamps. And we can go along, adding 3 each time. Okay? So see if you can now finish this. See if you can come up with the graph and the equation on your own. Pause the video here, use your notes, do the graph and the equation, and restart when you're ready. So making a graph of this, hopefully you've tried, and so now we're going to check. Here, my top row, as always, is X. My bottom row, as always, is Y. So I'll label this X is my months, and Y is my stamps. My top row just goes from 0 to 8. So I can just go 1, 2, 3, 4, 5, 6, 7, 8. My bottom row goes from 0 to 34. So I think I can count by 2s here. All right. So now I have my graph set up. I have my X and my Y. I have them labeled. So now I can start with my points. My first point is the point 0, 10. So 0, 10 over 0, 10. Next is 1, 13. Over to the 1, up to the 13. And we can continue. 2, 16. 3, 19. 4, 22. 525, 628, 731, and 834. And draw the line that connects those points. That leads me to the equation, and this equation is a little trickier. So the way we think about this, again, is how are we here? So my y in this case will equal my starting place, which is 10, plus my rate times x. Well, my rate, how much is it changing each time? Each time we increase by 3. So my rate is 3 times x. And this is my trick for this one. Since I wasn't just multiplying by the same thing each time, I was actually starting at one point and adding something each time. But I always added by the same thing. So that's still my constant rate. My 3, that's my constant rate. But I had to start at 10. So it's y equals 10 plus 3x. So my next question is this a proportional relationship? And then how many stamps will Chinu have after 10 months? So these two questions that you are going to put into school for your check. I want to tell you if this is proportional, and I want you to tell me how many stamps he will have after 10 months. The last thing I want you to think about, and you don't have to enter this anywhere, but I do want you to think about it. I want you to think about if you could write a rule for how to tell if a relationship is proportional from its description, from its graph, from its an equation, and from its table. And how would you tell if it's not proportional? So we've talked about in this video. If you got to the end of this video and you're still not sure how would you tell, then I suggest going back to the beginning and listening through the part where I was talking about this. Otherwise, please contact me. So I want you to think about that. This is the thing that you need to make sure you understand at the end of this video. Otherwise, contact me. And then you also have your 2 questions that you will be putting into Schoology. Thank you so much. Please let me know if you have any questions and have a great day.